Or in other words, draw k objects from n distinguishable objects and arrange them in the k available slots. So after learning permutations, I felt confident that I can get that data scientist job at Google. So I applied again. And just like last time, 100 people applied. But when we got there, the recruiter said, you know what? We are just going to randomly select 5 people out of you. So immediately I wanted to know, how many ways can you select 5 people from a group of 100 people? Now hold on. I know how you can calculate how many ways you can fill 5 positions with a group of 100 people. I could just use permutations. But here they are just choosing 5 people from a group of 100. They are not being arranged among themselves. I don't know how to calculate that. Oh well, back to my mathematician friend. As for Google, I'll be back. Now here's what my mathematician friend told me. In order to solve problems like above, you need to know combinations. The number of ways one can choose k objects from a set of n distinguishable objects without bothering about the arrangement in which the objects appear is called the combinations of k out of n. This number is denoted by nck. It is sometimes read as n choose k. How do you compute this number? Once again, we are going to need factorials. The formula for the combination is nck equals n factorial by k factorial into n minus k factorial. This is very similar to the formula for permutations, but there is an extra k factorial in the denominator. This comes from the fact that we don't care about the order of the arrangement of the k chosen objects. Since they can be arranged in k factorial ways among themselves, we need to add this k factorial to the denominator. There is a property of the combination function that is good to remember. nck equals nc n minus k. So back to the job application problem. You can now calculate the number of ways Google can randomly choose 5 people from 100 applicants. It is 100C5. This number is actually 100 times 99 times 98 times 97 times 96 divided by 1 times 2 times 3 times 4 times 5. So what if they were to choose 95 people instead of 5? Well, remember the formula. The number of ways you can choose 95 people is exactly the same as the number of ways you can choose 5 people. Okay, now let's see whether we can apply combinations to solve probability problems. Suppose you have a box with 20 screws and 5 of them are defective. If you pick 10 screws at random, what is the probability that all 10 would be good? To compute the total number of possible outcomes in the sample space, we just have to compute how many ways you can choose 10 screws from 20. It is 20C10. Now to compute the favorable outcomes for our event, that is choose 10 screws from 15 good ones, this can be done in 15C10 ways. So our probability is 15C10 divided by 20C10. What is the probability that you would have chosen 2 defective screws out of the 10? The denominator remains the same. In the numerator, we have to choose 8 screws from 15 good ones and 2 from 5 defective ones. This can be done in 15C8 times 5C2 ways. Suppose you have 20 boys and 20 girls. You want to divide them into 2 groups of 20 members each. What is the probability that each group will have exactly 10 girls and 10 boys? So, to compute the number of outcomes in the sample space, you have to compute the number of ways in which 20 people can be chosen from a group of 40. This can be done in 40C20 ways. As for our event, we have to choose 10 boys from a group of 20 boys and 10 girls from a group of 20 girls. This can be done in 20C10 ways each. So the number of ways the selection can be done for both the groups is 20C10 times 20C10. Therefore, the probability of our event is 20C10 whole square divided by 40C20. We are one more step closer, but our saga continues. Want to continue the journey? Then subscribe and like. Now you can compute the probability of any event. Well, not quite. There are some special cases that you need to be aware of.